over some of the problems on the Graphing Piecewise Functions worksheet. You can use this as an additional tool to help you complete these questions. I am going to do 3 of these so that you'll have 3 that are already worked out. You can use as models to do the other ones. So the first one we're going to work through is number 2. Number 2 does have 2 pieces. So whenever I look at this graph, there's only going to be 2 chunks of lines on the graph. First thing you want to do with this type of situation is see where your boundary lines are. And you can see here, my top function is going to be x is less than or equal to -2. Bottom function is x is greater than -2, which means -2 is going to be my boundary. Once you figure out your boundary, you want to figure out which side of the boundary each piece is going to exist on. Since the top piece is less than, it is going to exist to the left. The bottom piece is greater than, so it is going to exist to the right. And actually, I'm going to write that in a different color so we can keep our colors straight whenever we're going through them. The other thing I'm going to decide is whether my dots are going to be open or closed on the boundary. So for the top piece, the one that exists to the left, there is a line under that inequality. So that dot is going to be closed on the boundary. And for the bottom piece, there is no line under the inequality. So that dot is going to be open. And I see my calibration is just a tiny bit off here. So we'll make the best of that we can. Now both of these pieces are horizontal. And since they are horizontal, I don't need additional points to graph them. All I need to do is actually draw those horizontal pieces. So for the blue piece, for the piece that exists to the left on the boundary, I'm going to go up to 6 and I'm going to put a closed dot because that dot is closed there for the left-hand piece. And because it is existing to the left, I'm going to draw my arrow going off to the left-hand side. For the red piece on the bottom, I'm going to go on the boundary up to a height of +2 and put an open dot. And this piece exists to the right, so I'm drawing my dot to the right. And that's how you would graph a piecewise function with 2 horizontal pieces. The next one we're going to look at is number 2. I'm sorry, that was number 2. The next one we're going to do is number 4. Number 4 also has 2 pieces. This one has a boundary at +2. So I'm going to have my dotted horizontal line here at +2. The top piece does have a closed dot. So it does have a closed dot. I'm going to try to calibrate this real quick here because it seems to be getting worse the further I go. Okay. So the top piece, again, that is a closed dot, and this piece would exist to the left because it has the less than or equal to. The bottom piece is going to be an open dot, and it is going to exist to the right. Now, both of these are diagonal. And because they are diagonal, I'm going to need 2 ordered pairs to graph them. One of your ordered pairs is going to be on the boundary line, and then the other ordered pair is going to be something within the boundary. So if we look at the left-hand piece first, you can see it's x is less than or equal to 2. My boundary is at 2. So I'm going to plug in 2 for the x in this top piece. So you see what I highlighted there? That is the piece of the function I'm going to use. I'm going to replace the x in that function with a 2. So I have -2 and then +2. And that's going to simplify to 0. Now, as I said, that is a closed dot. So that is the ordered pair 2, 0, because 2 is what I plugged in, 0 is what I got back. So I have a closed dot down there at 2, 0. Now I need another value to plug in. We need something else that is within the boundary. This is the piece that exists to the left of x is 2. So I need an x value that is less than 2. So you're talking 1, 0, -1, -2. Any of those would work. I'm just going to go ahead and plug in 1 because it's close, but it is still within the boundary. So again, I'm plugging into where this highlighted yellow is. I'm replacing the x there with a 1. So I have a -1 plus 2, which would be a +1. So that ordered pair is going to be 1, 1. By the way, like I said before in part 1 video for 1-3, any dots that are not on the boundary line are automatically closed. So just know that if you have to deal with an open dot, that's only on the boundary, it's nowhere else. To connect these, you start on the dot that is on the boundary line and you draw through the other dot. So I start on that boundary dot and draw through the other dot. And now we're moving on to the piece on the right. So again, I need 2 values to plug in. The first one should always be your boundary x value. So I'm going to be plugging in 2. Now I'm going to be using this highlighted blue piece. So I'm using the x -2. So I'm replacing the x with the 2 and then finish out the -2 that's in the equation. That gives me 0, which means this point is 2, 0. Now, according to what I wrote with the boundary here, this is supposed to be an open dot at 2, 0. But notice, when you go to 2, 0, there's already a closed dot there. So even though you're drawing an open dot over top of that closed dot, if this weren't in color, all you would be seeing was a closed dot. So it is okay if you have an open dot over top of a closed or a closed over top of an open, that just automatically makes the dot closed. Now we need one more value that is within this region. So this is the region of values that are greater than 2. So I need an x value that's greater than 2. So let's try 3. So my equation is x -2, so it becomes 3 - 2, which is 1. And that's the ordered pair, 3, 1. And again, that's going to be a closed dot because it's not on the boundary. To connect your dots, you start on your boundary dot and draw through the other dot. And there's what our graph would look like for number 4. Diagonal lines do take a bit more work than horizontal lines, but you still only need the 2 ordered pairs in order to graph them. Now, normally I would do number 6, but because of my little picture in the bottom that has the image of me writing on the board, I'm going to do number 5 because I have more space to write, basically. So let's scroll down here, do number 5. So if you are watching this video, especially if you attended in class and you saw me work out number 6, you have an additional example here with number 5. So number 5 has 3 pieces. And because there's 3 pieces, that means that we now have 2 boundaries instead of 1. We have a boundary at x is -2, and we have a boundary at x is +2. All 3 of these pieces are diagonal. My top piece is going to exist to the left. The piece in the middle is going to exist in between the boundary lines. So instead of like before, I only had a left and I had a right, now I'm going to have a left, I'm going to have a middle, and I'm going to have a right. And so the bottom piece, again, is going to exist on the right. So let's go through on the top, that's going to be a closed dot. For the middle, that's going to be an open to an open. And it doesn't quite look like an O there. And then the right piece is going to be a close. So for the left, again, I need to plug in my boundary first of -2. So that's going to be -2 minus 1, which is -3. So that's the ordered pair -2, -3. That is a closed dot. Notice it is on the boundary. And then I'm going to plug in something else that is less than -2 because I'm looking at the x values that are to the left of -2. So we can plug in -3, and that would be -3 minus 1, which is -4. That's the ordered pair of -3, -4. So -3, -4 is down here. So this dot line is going to go like that. Again, you start on your boundary and draw through the other dot. Now the middle equation, I really like graphing the middle equations because there's no guesswork about what x values you have to plug in. You're plugging in the x's, the values that the x is in between. So it says here x is in between -2 and 2. It's greater than -2 but less than +2. So that's what you plug in. We're going to plug in -2. So we have 2 times -2 plus 1. Again, I'm using that middle equation for this one. So that's what I'm doing here. I'm using that middle equation. That's going to be a -4 plus 1, which is -3. So that is going to be the point -2, -3. And that is an open dot. Well, notice -2, -3, open dot over top of closed dot. That's okay. That happens sometimes. Your other boundary line is at 2, so that's what I plug in for my second value. Again, for the middle, you're always plugging in those 2 boundary numbers. So I have 2 times 2 plus 1, which is going to give me 5. So that's the point 2, 5. So 2, and then up at 5, that is also open. And then for the middle, you just connect dot to dot. There should be no arrows for the middle piece. Let's see if I can make that a little bit better. There's no arrows with the middle piece, so you're just connecting your dot to dot. Now for the right piece, I am going to plug in my 2 because that's my boundary. And again, for this right piece, we're going to be using this bottom equation here. So that's going to be 2 minus 2, which is 0. So that's the ordered pair 2, 0. That is a closed dot. That's down here. And then I need to pick some other x that is greater than 2. So let's try 3. So that's going to be 3 minus 2. That gives us 1. So that's the ordered pair 3, 1. So 3, 1, which is right there. Start on the boundary dot, draw through the other dot. So there's my equation for 5. So those will go the yellow. This one was blue. And we'll see how this looks if we do the top one in green. Those are the ones in green. Sometimes it helps having those colors so that you can distinguish between them. So the rest of the worksheet does need to be completed. You can use these examples to guide you. The last 4 questions, you're already given the graph. You need to write in the equation. You can use the 1-3 Piecewise Functions Part 2 video to help you with number 9 through 12 on this worksheet. So give this your best shot. Do what you can with this. Make sure you are careful with your boundaries so you're not crossing over from one boundary into the next. And as always, with everything that we do, contact me if you have any questions.